Now we are going to have some tutorials to see how the problems related to electromagnetism can be solved. So, without being able to solve problems, electromagnetism will be hardly of any use. So, tutorials are very important, and after covering a significant portion of the topic, we will always have a tutorial. The first tutorial is about differential calculus with vectors, because most of you were already familiar with vector algebra. We do not have any tutorial on vector algebra. It starts with vector calculus. And in differential calculus, we have learnt gradient, divergence and curl, mainly these three aspects of vector differentiation. So, this tutorial is about the gradient, divergence and curl of a vector. Okay, so during the tutorials, what I will do is, after explaining the problem, I will pause for a while. You can pause the video during this time and you can try solving the problem. After you have attempted to solve the problem, if you have solved it completely fine, you can move to the next problem. If you could not solve it, I will explain how the problem can be solved. You can go through that, and there will also be parts. So, the problem will be divided into different parts, and you can pause the video after some parts and then try to solve the problem, remaining part of the problem, and then look at the next part of the video. You can proceed this way. So, we have this problem that we take the gradient with respect to x1, y1 and z1, that is gradient 1 of the magnitude of this displacement vector r12. How do we, so you can now pause the video and try solving it yourself. Okay. After you have tried solving the video, let's try solving the problem. Let's see how it can be worked out. So, the magnitude of r12 vector can be given as x1 minus x2 whole square plus y1 minus y2 square plus z1 minus z2 square root of this quantity. And we can write the gradient of a scalar function r12 as del r12 del x1 along x cap direction plus del r12 del y1 along y cap direction plus del r12 del z1 along z cap direction. So, if we calculate one component of it, the first component, let us say del r12 del x1, we will obtain x1 minus x2 over r12. Similarly, for del r12 del y1, we will obtain y1 minus y2 over r12, and for del r12 del z1, we will obtain z1 minus z2 over r12. Now, if we add all these components with appropriate unit vector multiplied to the components, we will get x1 minus x2 along x cap direction plus y1 minus y2 along y cap direction plus z1 minus z2 along z cap direction over r12 magnitude, the magnitude of this r12 vector. So, this is this one at the numerator is nothing but r12 vector, and that is divided by r12 magnitude. That means the gradient of r12 magnitude is a unit vector along r12. That is what we have obtained by solving this problem. Okay. After that, let us move on to the second problem. In the second problem, you are asked to calculate the divergence and curl of a given vector field. V is the given vector field, that is expressed as y squared x cap plus 2xy plus z squared y cap plus 2yz z cap. This is the vector field, and you are asked to find out the divergence and curl of this vector field. Now, you can pause the video, try it yourself, and then replay the video. Okay. If you need some help in solving this problem, this is the way we can calculate the divergence in the first step. That is, the divergence operator is x cap del del x plus y cap del del y plus z cap del del z dot the vector field y square x cap plus 2xy plus z square y cap plus 2yz z cap. That means del x will operate only on the x component here. Similarly, del y will operate on the y component. That is this one, and del z will operate on the z component, this one. Okay, so this is the way we can calculate the divergence. And if we want to calculate the curl, then curl of a vector A is given as this determinant x cap, y cap, z cap, del x, del y, del z, ax, ay, az, where ax, ay and az are the x, y and z components of the vector respectively. So, for this given vector at our hand, we can calculate also the curl of the vector using this expression. Okay, now let us move on to the third problem. Here we consider a scalar field given by t equals x square y cube z power 4, and in the first step you are asked to calculate the gradient of this function, that is grad of t, the scalar field, and the second step you are asked to calculate the curl of the gradient of this function. So, we have a scalar function. If we calculate its gradient, we are going to have a vector at hand, and in the second step you are supposed to calculate the curl of that vector quantity. Then the third step is to see whether the result of this curl that we got was expected. Did you expect this kind of a result? Here you can pause the video and try the problem out. And for this problem, I am not going to offer a solution. This is for you to work out and see whether you get the expected solution. I will only give you one hint that we have found out that the curl of the gradient of a scalar field is always 0. So, in step 2, you are supposed to get 0 as a result, and if you have got that, that is the expected result. If you have got something else, some non-zero value in the second step, then you better recheck your calculation.